In the previous video, we talked about slope-intercept form of a line. So now we're going to look at point slope because there's multiple representations for a line. And we've looked at slope-intercept, which is y equals mx plus b. So when we look at the slope-intercept form of a linear equation, we have y equals mx plus b. So slope-intercept form looks like this. And we talked about this in the previous couple of videos where m is your slope and b is your y-intercept. And every equation gives you something particular, some particular characteristic of the line, and there's a reason we use the different types of equations. Well, in this one, we're going to look at point slope, and then we'll look at general form. Point slope is the equation is when we actually have a point and a slope, whereas slope-intercept has a slope and a y-intercept. Point slope gives you the opportunity to plug in a slope and a point. And what point slope looks like is y minus y1 equals m times x minus x1. And when you're looking at point slope represents another format of the same line we're talking about with slope-intercept. So you can take a single line and put it in any format you want and manipulate the equation any way you want. Point slope actually is a derivative of the slope formula. So let's review what the slope formula looked like. If you guys remember, slope formula was y2 minus y1 over x2 minus x1. Well, if we do a simple cross multiplication here, we can actually arrive at the point slope formula by using the slope formula. So I'm going to put m over 1. And then I'm going to cross multiply. If you guys remember, when you have two equal ratios, this is a proportion, we can cross multiply. And when I cross multiply, I get 1 times y2 minus y1, which gives me y2 minus y1 on the left. And I have m times x2 minus x1, which gives me m times x2 minus x1 on the right. And you can see that is the same structure. So point slope is actually derived from the slope formula itself. Now don't worry about the little subscripts, the 1s and the 2s, and why it's a little bit different. When we use the point slope formula, we're actually trying to find the equation of a line and not the specific values. So we're not going to be plugging in 2 points as we would here. We're only going to plug in 1 point. So when I have point slope, let's say my point slope is this. What this represents is a line that has a slope of 4, so m equals 4, and passes through the point x1, y1. So if we look at our equation, x1 is actually 1, and y1 is actually 3. Don't get confused, because if you look at the original equation, notice that y1 is being subtracted, as is x1. That is why it's positive 1, positive 3. We always do the opposite of the way that the equation is written. So you can see this is the equation of a line that has a slope of 4 and passes through the point 1, 3. So let's look at another example. So I'm going to move this up a little bit. So I'm going to give you another equation. So let's say I have y plus 5 equals 3 times x minus 7. So again, point slope. Slope is 3. That's the slope of my line. And this line passes through the point. You go opposite, 7. But look here. I have positive 5. But the original equation, if you look at it, subtracts y1. This is the same thing as subtracting negative 5. So remember, we go opposite, so this passes through the point 7, negative 5. So that's how you read point slope. Now you can also take point slope, and we can actually make slope-intercept from manipulating point slope. So for example, let's take this equation. If I have y plus 5 equals whoops, let me rewrite that. If I have y plus 5 equals 3 times x minus 7, I can convert that into the format y equals mx plus b if I want to. And sometimes it'll be better to leave it in point slope, and sometimes it'll be better to actually convert it. So what we have is y plus 5 equals, now let's use the distributive property. 3 times x is 3x. 3 times negative 7 is negative 21. I just used distributive property. Now to get to this point, I have to isolate the y, right? I want to get this all alone. So I'm going to take this 5 and I'm going to move it over to the other side. So y equals 3x minus 26. So this equation, in essence, is the same as this equation. But one of these, this is in point slope form, point slope. And this one, oops, my pen decided to poop out on me again. That's in point slope, and this is in slope intercept. So you can see each equation has its own applications and own purpose. It depends on what you want to see, what characteristics you want to see about the line. Slope intercept form tells you the y-intercept and the slope. Point slope tells you the slope and one point that is on the line. This point that is on the line is not necessarily the slope the y-intercept. It is just a point on the line. The neat thing about this is I can take any point on that line and plug it into point slope and plug it into this formula, any point on that line, and when I rearrange it, I will still get the same slope intercept form. So just sometimes because an equation doesn't look the same doesn't mean it isn't the same. So that is how you do point slope form.